All right, we're going to do a couple more types of two-step equations, okay? Now, just bear with me. There's no essential question here. We're just going to get straight to it. I want to tell you that equations like 2 times quantity x plus 5 is equal to 40, okay? It's like, and I know, watch out, p times x plus q is equal to r, right? Where these are all different numbers. It contains two factors. The two factors are p and q plus x plus q. Those are the two things that are being multiplied with one another. So because there's two factors, it can be solved in 2 steps. Now, just follow along with me and then see if it makes more sense to you after a few examples. Okay, if I take a look at this problem, 3 times x plus 5 equals 45. So really there's two things being multiplied, a 3 and an x plus 5. So let's look at it as a picture. Okay, if I take this big rectangle here and I cut into 3 pieces, I've got 3 x plus 5s, x plus 5, x plus 5. I know all of that is equal to 45, okay? So if I think about that, all of it is equal to 45. If I cut them into thirds, then really I can think of this as just one of those, x plus 5, would be equal to a third of 45, right? If the whole thing is 45, there's 3 of them, if I just cut it into thirds, then one of those is a third of 45, and in this case that's 15. All right, so that would be the first step. You're cutting that bigger piece into 3. You're dividing that by 3, and then ultimately you would subtract 5 on both sides, and you'd find out that x, right, that just drops down, is equal to 10. And that makes sense. 10, that's 15 plus 15 plus 15 equals 45. Okay, let me show you just the second method of doing that same thing. So normally I wouldn't have you draw it all out, but you can say, look, if these two things are being multiplied with one another, what I could possibly do is I can just, before I go ahead and just try to distribute, is why don't I just divide both of those by 3? And that's what he did up here. I took this big piece and I just cut it into 3. And I find out that x plus 5 is equal to 15, which is right here. And then you go through that step, right? You subtract 15 on both sides again, and then that drops down, equals 10. Either way, I still get the same answer. I'll show you one last thing, which foolproof way, you could always do it this way as well. I'm not telling you, you don't have to not do it this way, but I'm just trying to save you some time by showing you this way. This is the preferred way that they show in the book, and it's good to understand that. But you can also do it this way. See, Mr. Ramos, look, I know I'm supposed to distribute. That's what you've been teaching me. 3 times x plus 15 equals 45. Yeah, okay. And then, Mr. Ramos, you told me to get rid of subtract or addition. In this case, I'm going to subtract 15 on both sides. Okay, 3x equals, what is that, 30? Yeah. And then, Mr. Ramos, you told me to divide by 3, and you find out that x is 10. Yeah, you can definitely do that way. I'm not telling you that's wrong, but I'm telling you, trying to show you a different method so that you have more tools in the tool shed, if you will. All right, let's try a couple more examples. Okay, I'm going to show you the way the book wants you to do this. Okay, look, 5 times this equals 20. So if I divide both sides by 5 before I even distribute, that eliminates that. I'm left with n minus 2 equals 4. In that case, all I have to do is add 2 to both sides, and I find out that my answer is 6. I could double check my work. 5 times 6 minus 2, does that equal 20? Question mark. Does 5 times 4 give me 20? Check, that does work. Now if you're like, I'm still not getting this, Mr. Ramos, I want to just distribute, I'm just dying to distribute. Well, I'll show you that it still works out. 5n minus 10 equals 20. Get rid of any addition or subtraction first. So in this case, I add 10. 5n equals 30. Divide by 5, and I find out that n is 6. Go back and plug it back in. Well, I already did that here for you, but you can see that it's still going to give you the same answer. So I'm showing you both ways. Again, the book prefers you to know this way. Might help you out later on, and let's see if it works on this next one. All right, so here we go. Negative 7 times 6 plus d, it's a 6 there, equals 49. All right, so right off the bat, I'm going to divide by negative 7. I do that, so that goes away. I'm left with 6 plus d equals negative 7. In this case, all I have to do is one easy step, subtract 6 on both sides, and I get negative 13 as my answer. Okay, and I could double check. Negative 7 times 6 minus 13, does it equal 49? And your answer to that would be, yes, it does equal 49. Now, again, if you're just still not comfortable, you're like, oh, man, I don't know, learning all this new stuff. Why learn? Why? If that's you, and say, okay, look, you can go old-fashioned and go ahead and distribute. It's not going to give you a wrong answer. It just might take you a little bit longer, some extra steps. Okay? And the opposite. You say, no, Ms. Ramos, no, I'm fast this way. I can do it this way. You know how you guys talk. Then whoops, it should be 90, 80, 91. You can see where it could create a little bit of an issue here. It's like, oh, 91, I don't know, 91 divided by 7, does that work out? In this case, yeah, it does work out. It should give you negative 13. And then you check your work and you find out that it's the same. So you're stubborn. You're not big on the growth mindset and pushing yourself. Well, this is where the books method comes in handy, okay? I'll show you the both ways here. So look, if I go to the books method says get rid of this, divide by this fraction. Well, I remember dividing by a fraction is the same as multiplying by its reciprocal, called the multiplicative inverse. That helps me in this case because now I'm left with this beautiful little n plus 6. And over here, I do a little cross canceling. 1 and 5, I get 15. Oh man, subtract 6 and bam, I get my answer, which is 9. Let me double check. I'm not sure that's right. I'm just throwing down some numbers here. I'm not sure if this is going to equal 10. Question. Well, I get 2/3 times 15. Will that equal 10? Question mark. Well, 1 and 5. Holy moly, it does equal 10. It's like magic. Okay, this is the way the book wants you to do it. Get rid of that first little number up front by dividing it, or in this case, multiplying by the reciprocal. Say, now, Mr. Ramos, I want to go ahead and distribute because I'm just that type of student. Well, look what happens in this case if I distribute 2/3 n, and then 2 times 6 is 12. 12 divided by 3 is 4. All right. Subtract 4 on both sides. Okay, 2/3 n equals 6. Oh, I still have to end up multiplying by the reciprocal. Dang, I thought I was going to get away from doing that. No. No one gets away. 6 times 3 divided by 6 times 3 is 18 divided by 2 is 9. It is 9. Then I double check and I get that. A little bit more work. You say, no, I could do that faster. Look, I know some people are stubborn, but I wanted to get you to start thinking this way because it does come in handy a little bit more. All right, I've already looked at the video. It's a long one, so I will stop right there.